Hey everyone, welcome back to the channel. So pop up a hello in the live chat and let me know where you are turning in from and if the audio and video perfectly clear. Today we are doing a massive, comprehensive deep dive into cloud computing, virtualization, and cloud security, spanning Unit 1 through 5. We'll look at both the quick concepts and the heavy long answers, topics like symmetric cryptography, hypervisor vulnerabilities, and industry standard. And get your notes ready, and let's jump right now. So let's start with the foundation of Unit 1 and Unit 2. So over here, we are going to learn why do we even need the cloud. So it's very simple, on-demand scalability and shifting from massive capital expenditures, capex, to operational and pay as you go billing, opex, operational expenditure. And so what exactly cloud is? Okay, fine. Fine. Necessity of cloud. The cloud computing is necessary for its ability to provide on-demand, scalable, and cost-effective computing and storage resources. So it is useful for reducing capital expenditure (capex) by allowing organizations to pay only for consumed services, that is operational expenditure. So additionally, it enhances global workforce mobility and it's even speed up time to market and even improve resource utilization through multi-tenancy and virtualization. So next, so we are going to know what exactly is cloud. So officially, it's a model for providing on-demand network access to a shared pool of configurable resources like networks, servers, storage. So that can be spun up with minimal provider interaction. So define cloud computing. So cloud computing is a model for providing on-demand network access to a shared pool of configurable computing resources. Example networks, as I said, example networks, servers, storage, and applications. So these can be rapidly provisioned and released with minimal management effort or service provider interaction. So it offers scalability and location independency via via a pay-per-use utility model over the internet. So this is the important thing. So why is high security vital? So you need to know why high security is vital. So because of a shared physical infrastructure. So what is the particular shared physical infrastructure offered by cloud computing? So if you are sharing hardware, so you risk issues like VM escape. So that is virtual machine escape, and data leakage and cryptojacking. So that's the issues. These are the risk issues you are going to face. So let us see in detail. So necessity of high security in cloud. Necessity of high security in cloud. High security is vital in the cloud because shared physical infrastructure create risk like I said before VM escape and where actually attackers break isolation. So where the attackers will break isolation to access others users data. So if you are if you are storing a particular data over there, so has the same virtual machine, they will try to perform this particular risk present in your particular cloud. So they will break isolation to access your users data. So like before that, this particular isolation, if there is a proper isolation, it ensures confidentiality, integrity, and availability against threats. So like this high security ensures confidentiality, integrity, and availability against threats like cryptojacking and data leakage. This high security can be enabled with a strong security. This particular strong security prevents unauthorized access. If there is an unauthorized access, so for your data, your particular user data, it is going to prevent unauthorized access. And not only that, it ensures compliancy. So like belief between the particular uh, cloud computing service providers and the cloud users with the legal standards. So here we have a legal standards. Those are GDPR and HIPAA. This GDPR stands for General Data Protection Regulation, and HIPAA stands for HIPAA stands for HIPAA stands for so if you're having some electronic protected health information. So if you're having any health like electronic protected health information, so this is stored and processed or transmitted via cloud servers. So these particular health records meet strict privacy and security standards. So for this, we will have some formal business associate agreement. And next, we are moving to so what about non-repudiation? So this non-repudiation ensures no one can deny their actions in the cloud. So what they are performing in the cloud, they are not able to they cannot able to deny that they did this particular thing. So this particular non-replication present in the cloud will track this it will track each and every one using digital signatures and audit logs and blockchain. Okay, so we'll discuss in depth non-repetition in cloud. So non-repetition ensures that a party in a transaction, if a party is performing in a transaction, they cannot able to they cannot deny so their involvement. So they cannot deny their involvement or the validity of their actions. So that no need of having any issues like they whether have done this or not. Just have a validity of their actions. Basically, in cloud, this is achieved through digital signatures. For each and every transaction, there is going to have digital signatures and audit logs. which is performed through blockchain based tracking. So for everything is we are going to use a blockchain technology over here for tracking. So this type of mechanism provides undeniable proof of activity. So this particular mechanism provide undeniable. So the person cannot able to deny. So here did not perform the particular task. So what they cannot able to deny the proof of activity, such as data access, related to data access or modification. So this ensures accountability and legal evidence. Even it shows that what they are accountable for, and when it can produce for legal evidence for all parties involved. Next, how does user isolation protect us? Okay, so isolation ensures your virtual machine is running independently on shared hardware. What was the hardware shared for you by your cloud provider? This particular VM runs independently on shared hardware. Basically, so in this particular cloud, we usually have hypervisors. These hypervisors will enforce these boundaries. So this hypervisor enforces the boundaries. Ensure the boundaries. So if you have if you are having any compromised neighbor in a virtual machine, so it will ensure the boundaries, so that so that your neighbor VM cannot look at your data. So when the particular borders are defined properly, so your particular neighbor virtual machine cannot look at your data. So let us see in detail. So how isolation of users ensures quality security. Isolation ensures that each virtual machine VM operates independently on shared hardware. Ensures that each virtual machine VM operates independently on shared hardware, like accessing others compromise or malicious activities in the one VM. So one VM does not impact the performance or security of others. By using the hypervisors, by using hypervisors, so in our particular cloud, this particular hypervisors will enforce those boundaries. As I said, like if we want to enforce these boundaries, so finally, the cloud maintain data confidentiality and prevents unauthorized lateral movement. So it will prevent unauthorized lateral movement. Just a minute, I will be back. Ome, మధ్యాహ్నం ఇచ్చిన వేసుకున్నాం అండి. మరి అదే కదా కొంచెం బాగా ట్రై చేసి తెచ్చుకోండి. అది ఒకటేనంట వేసుకునేది నైట్ వస్తాను డాడీ పోయి మిద్ద మీద నీళ్ళు కొట్టురాపు. వర్షం పడుతుందా? ఏ పడట్లేదు వర్షం. బకెట్ నీళ్ళు కొట్టురాపు. బకెట్ నీళ్ళు ఇన్సూరెన్స్ కాల్ బిక్కుతున్నారా చూడండి. ఏంది నీ మొక్కం కనిపిస్తుంది? ఏంది కెమెరా ఆన్ చేస్తున్నా మొక్క ప్రింట్ మొక్క కనిపిస్తుంది. ఏం చేస్తున్నావు? ఏం బిక్కుతున్నావు? లైవా? ఎవడికి లైవ్? And last and finally, in Unit 2, we are going to discuss about how do we manage all of this through a cloud management console. So that's handy web-based GUI dashboard where you click to provision resources instead of typing complex commands. Okay, so let us get dive into this particular thing. So management console in cloud. So a cloud management console is a web-based interface or GUI that allows user to manage their cloud resources and services. It provides a centralized dashboard to provision virtual machines for configure and storage and monitor performance, and even you can able to manage security settings and IAM infrastructure infrastructure access management. Okay, IAM for identity and access management roles. So this simplifies administrative tasks by replacing complex CLI commands with an intuitive and visual control center. So now let us move over to unit 3, 4 and 5. So let's clear up core technical terms. So first we'll start with the virtual machine, that is VM. So this is nothing but it is a software based emulation of a physical computer. So where it's running its own OS and managed by a hypervisor. So let us discuss in detail. So define virtual machine. So virtual machine is a software-based emulation of a physical computer that runs an operating system and an applications just like a physical machine. So it operates in an isolated environment on a physical host, so managed by a hypervisor. So this allows multiple independent guest systems to share the same hardware resources and improve efficiency and scalability and hardware utilization. So next, move on to data center. So this data center is nothing but an actual brick and mortar foundation housing the physical servers and cooling and power that translates your cloud clicks into physical processing power. So what is the role of data centers in cloud? So data centers serve as a physical foundations of the cloud, housing the hardware, servers, storage systems, and networking equipment. So these are required for running virtualized services. So they provide the necessary power, cooling, and high-speed internet connectivity. So these all ensures that cloud resources are available 24 by 7. Essentially the data centers translates the digital cloud request into physical processing power. Next, move on to cyber attack. So this cyber attack is nothing but it is not accidental. It's an intentional and unauthorized attempts. So which was done to breach a system. So in cloud, this looks like DDoS attacks, and we have a malware injections or hypervisor exploits, so targeting your data. So what is a cyber attack? A cyber attack is an intentional attempt by unauthorized individuals or organizations to breach the information system of another individual or group. In cloud computing, these attacks aim to compromise data confidentiality, integrity, or availability. So common examples includes DDoS. DDoS. So DDoS stands for Distributed Denial of Services attacks. So malware injections and hypervisor exploits. So these are designed to for stealing your sensitive data or disrupt your cloud services. Next, move on to HPVS hypervisors. So these are the vital virtualization software layer splits your physical hardware into multiple virtual machines. For why they are splitting into multiple virtual machines? For providing the core multi-tenancy of the cloud. Let us discuss in detail. So define HPVS. HPVS stands for hypervisors. These are are a virtual layers that allows multiple virtual machines. So to run on a single physical host, we have a hypervisor which is going to present a virtual layer. So we have different virtual machines. So we have it allows this multiple virtual machines to run on a single physical host, so that they manage hardware resources like CPU, RAM, and storage, and even by ensuring isolation between users. So one user to another user, it is going to provide isolation between users by separating the OS. So by separating the OS from the physical hardware and hypervisors enables efficient resource utilization. So uh, this enables efficient resource utilization and even scalability, and the foundational multi-tenancy required for cloud computing. Next, move on to data ownership. So when you're preparing for examinations, remember the data ownership almost always remains with the customer who owns the data. The data ownership will lies with him, remains with the customer. So the provider is just a processor. So the provider who is providing this cloud services, just a processor. So like your rights are legally protected. So when you are using this particular data, then when you are storing this data, the ownership will lie with the customer. For that reason, your rights are legally protected in the service level agreements. So what are the service level agreement you made with the cloud provider? So it is going to it is going to protect your rights legally. So describe ownership of data in cloud. So data ownership in the cloud typically remains with the customer who retains all legal rights and responsibility for the data. So while the provider hosts the physical infrastructure and manages security of the platform, and they act only as a data processor. And ownership is defined in the service level agreement, ensures users can access, modify, delete their information at any time. Now we will move on to long answers. So now let's tackle the heavy long answer concepts. So top of our first topic will be digital signatures and cryptography. In general, digital signatures use asymmetric crypto. So if they use asymmetric crypto, give us three things. So when they are using asymmetric crypto, they give three things to us. So one is integrity, authentication, and non-repetition. So here the sender hashes the data and encrypts it with their private keys, and the recipient de- uh, decrypts it with the sender's public key. So now the recipient decrypts it with the sender's public key. So now let's break down the security codes. The first is confidentiality. So nothing but keeping data hidden from unauthorized eyes. So nothing but for keeping data hidden from authorized use, they will use some tools like AES for data is stressed. And next security goal will be integrity. Integrity is nothing but keeping your data untampered and so how it is going to perform, so by verified by a hashing. And next goal is nothing but access control. So this can be achieved by regulating entry via identity and access management, that is IAM. So here we are already discussed that we are going to have asymmetric crypto, right? So for this access control, it is going to have symmetric cryptography. For digital signature, asymmetric cryptography. For access control, we use symmetric cryptography process. So unlike asymmetric, symmetric uses a single secret key for both encryption and decryption. So we will use only symmetric single secret key for both encryption and decryption. The sender converts plain text to ciphertext using an algorithm called AES and sends it, and the recipient uses that same key to revert it. So it's a super fast for big data volumes, but key management is a massive challenge. So let us discuss in depth. So discuss digital digital signature. So A, confidentiality, B, integrity, C, access control. And we have one more thing. So we have to explain the process of symmetric cryptography. So first we will discuss about digital signature. So digital signatures uses symmetric cryptography to provide integrity, authentication, and non-repetition. So here a sender hashes the data and encrypts that hash with their private key. So okay, that's with the sender. And coming to recipient, the recipient decrypts it using the sender's public key. The hashes match. If the hashes match, the data is untampered. So coming to security goals, confidentiality. So ensures only authorized users. It ensures only authorized users access data. In the cloud, this is achieved via encryption. So by using AES for data at rest and identity management and integrity. It guarantees its data remains accurate and unaltered. So this is going to be verified using hashing and digital signatures. So detect unauthorized modifications. And next, access control. This access control regulates who can view or use your resources by this is going to be implemented via identity and access management and role-based access control RBS. And symmetric crypto And the symmetric cryptography process uses single secret key for both encryption and decryption. So this key exchange, so both parties must secure a secret key. So key exchange, both parties must securely share a secret key. And coming to encryption, the senders use a algorithm like AES and the secret key to convert plain text into ciphertext. And next, transmission. The ciphertext is sent over the network. Next, decryption. The recipient applies the same secret key and algorithm to revert the ciphertext back to plain text. So that is efficient for large data volumes, but requires robust key management, as anyone with a key can decrypt the information. And our next topic will be isolation vulnerability configuration mistakes. Let us see what happens when isolation fails. One is hypervisor flaws. So this can cause a virtual machine escape. So particularly where an attacker breaks out of their virtual machine to hijack the host hardware or neighbor virtual machines. And a shared resource exploitation. So a noisy neighbor virtual machine hogging CPU or RAM, so causing a DOS. Causing a denial of service. So it is going to cause a denial of service for you. And next, if isolation fails, the side channel attacks. There will be side channel attacks. So which is monitoring hardware characteristics like catchy timing to steal crypto keys. So this common misconfiguration impacts. This common misconfiguration impacts. So this is how most breaches happen. Publicly exposed S3 storage buckets leads to data leakage. So if you publicly expose your S3 storage bucket, this may lead to data leakage also. Even weak uh, weak identity and access management rules leads to account takeovers. Even bad firewall rules also let crypto hijackers run up their bill. So resource abuse. So by disabling logs leads to complaints failure also. Let us discuss in detail. There will be plain text by using encryption. By using encryption, we'll convert this particular plain text to ciphertext in encryption. So then it becomes encrypted text. By using the private key, this is going to perform decryption, converting ciphertext into plain text. Now we'll move to we will dive into vulnerability issues in isolation. And next, we are going to analyze the impact. We are going to analyze the impact of common configuration mistakes. So, first, vulnerability issues in isolation. In cloud computing, In cloud computing, isolation ensures that multiple users sharing the same physical infrastructure cannot access each other's data, and community vulnerabilities occur when these boundaries fail, and primarily through the following issues: hypervisor flaws. As a software managing virtual machine, any bug in the hypervisor can lead to virtual machine escape. An attacker breakouts of their virtual machine to gain cryptography, gain to gain control over the host machine.
ఎనిమిదింటికి వేసిందా చుక్కలు అన్నయ్య? ఎనిమిదింటికి వేసిందా చుక్కలు? ఏం చేస్తుంటారు అన్నయ్య? పనుకునేటప్పుడు మీకన్నా గుర్తుండద్దా నేను?
తిందామా అన్నం?
ఎనిమిదింటికి ఏం పనుకోవాలి. 8:30 ఒకసారి నేను ఏ పొద్దు బయట వరకు అమ్ముతాను.